row, column, or diagonal. In our case, we're solving the 8 queens problem. We'll animate the logic of backtracking as we go. One decision, one square at a time. Here's the pseudocode we'll be walking through. The algorithm works by placing queens row by row, checking for conflicts, and backtracking when needed. Let's begin. We begin our recursive function, solve of row, at row 0. This function tries each column in the row until it finds a safe place for the queen. We check if the current square is safe using the IsSafe function. In the try phase, we're attempting to place a queen at a specific cell. If the cell is safe, we highlight it and consider placing the queen. If it's not safe, maybe it's under attack from another queen, we skip it and move to the next column. Once we find a safe spot, we enter the place phase. We place the queen on the board and move on to the next row. Each successful placement brings us closer to a complete solution. This continues recursively. Place a queen, move to the next row, and repeat. But what if we reach a row where no valid moves are available? That's where backtracking kicks in. We remove the last queen and go back to try the next column in the previous row. This back and forth continues until all queens are placed without conflict, or until all options are exhausted. Once we reach row 8, we've placed all 8 queens successfully. That means we've found a valid solution. Let's quickly recap how backtracking worked here. Try placing a queen row by row. If a placement is unsafe, try the next column. If all columns fail, backtrack to the previous row. Repeat until a solution is found. This logic is reflected directly in the code. As the algorithm runs, each step of the code is highlighted, showing exactly which part of the function is being executed. The n-queens problem is a great example of how backtracking can be used to explore complex search spaces. By visualizing each decision and its consequences, we get a deep, intuitive understanding of how recursion and backtracking work together. Try clicking through the steps yourself, experiment with different placements, and see how the algorithm explores the board. Thanks for watching. If you found this explainer helpful, don't forget to like, share, and subscribe for more algorithm animations.